Hello, and behind me is the Hughes H4 Hercules, which is a massive cargo seaplane built towards the end of World War II. So the United States were supplying their European allies during the war, but a lot of those ships were being sunk by German submarines, so someone came up with the idea of, why don't we fly the cargo over, and then that's how this aircraft came about. And in this video, I'm going to take you on a detailed tour of it. First, we're going to walk around the outside and I'm going to explain what's unique and interesting, and then we're going to crawl up into the cockpit and I'll show you what it's like in there. So let's get into it. I make videos about planes. This includes trip reports on board flights from around the world, and I also make detailed tours crawling through significant aircraft in museums. I'm also on Instagram and Facebook. The first point I really want to make is that this video footage really doesn't show how massive this aircraft really is. It's huge by 2022 standards, let alone the 1940s. To give you a bit of an idea, here's a Douglas DC-3, which was a big aircraft of that era, although you can see how it just pales into insignificance next to the massive H4 Hercules. In fact, it had the longest wingspan of any aircraft ever up until 2019, when the 6-engined Stratolauncher was created. Let's start at the rear and we'll work our way forward and then inside. At 113 feet and 6 inches, the tail span of these horizontal stabilizers is actually longer than a B-17 Flying Fortress's total wingspan, and the whole tail would flex 3 feet either left or right. Because it's so high above where I'm standing, it really makes everything seem smaller, and you'll notice that when I get to the engines, which look tiny. It had the world's first hydraulically actuated control systems, because the control surfaces were all massive and therefore heavy, and it would be impossible for a human to operate without any assistance. And we'll see more of that hydraulic system once we get inside. While Howard Hughes was the designer and contributed financially as well, the idea was created by a shipbuilder called Henry J. Kaiser. They planned to produce an aircraft capable of carrying 68 tons of cargo, which would equate to 750 troops or 2 M4 Sherman tanks. It was powered by 8 Pratt & Whitney R4360 Wasp major 28-cylinder engines, and again, because they're so far above me, they look tiny. Now here's the same engines on a Boeing C-97 Stratofreighter at Pima, which look much larger attached to a smaller aircraft. These produced around 3,000 horsepower and consumed 109 gallons of fuel per hour at cruise speed. They were fitted with 4 bladed Hamilton standard propellers, which were 17 feet and 2 inches in diameter. The aircraft was initially called the HK-1, recognizing both Hughes and Kaiser working together. It was nicknamed the Spruce Goose, although Howard Hughes wasn't a fan of that name, and it wasn't made of spruce wood anyway. In fact, it was made of birch, although the other name still stuck. The reason why it was built out of wood was simply because there were wartime restrictions on aluminium, and there were concerns that a metal plane of that size simply would be too heavy to fly. Hughes used a creative new way of making the birch stronger by using laminated layers of it glued together under heat and pressure, thus creating what was called Duramold. During the assembly, 7 tons of nails were used to hold it together, but when the glue set, they removed the nails to reduce the weight. Kaiser struggled through the early design stages, becoming increasingly frustrated with the limitations placed on it by the government, since it wasn't seen as a military priority. The other frustration was Hughes' perfectionism, and while it did drive him to design a good aircraft, he was difficult to work with. About 16 months after the project was approved, Kaiser resigned, leaving Hughes to continue it alone. The aircraft was renamed the H4 Hercules, and Hughes signed a new deal with the government to build just 1 example instead of the 3 originally ordered, as it became obvious that the war was coming to an end. The build continued with many lengthy delays, and it wasn't until 1947 that it was assembled and ready for testing, 2 years after the war had ended. An obvious question is why they went with a flying boat when most other large aircraft of that era were land-based. Now, the maximum takeoff weight was 400,000 pounds, which compares to just 135,000 pounds for the B-29, so airports just weren't equipped to carry such large aircraft. Now, the later B-36 had a similar maximum takeoff weight, although it was also initially limited to a small number of particularly large airports. Eventually, the infrastructure did improve and it wasn't a problem, but in 1942, when this thing was being designed, they concluded that a flying boat design was better. The aircraft only flew once, and it's unclear if it was intentional. On November 2nd, 1947, with Hughes at the controls and 14 media and industry reps on board, Hughes took them all for some taxi testing. After picking up some speed, it lifted off the water for around 26 seconds at 70 feet, for around 1 mile. Senators were grilling him about the potential waste of money, so this proved that the aircraft could at least fly, and here's footage of its logbook recording the moment. It's reported that Hughes did hope to fly it again, and it was maintained for many years in flying condition and in a massive climate-controlled hangar. But with worsening health, other aviation-related incidents, and further financial woes kept him distracted until his death in 1976. Now let's go inside this beauty, and first we'll take a right turn and check out the aft section. There's a window in the way, so I'll make do with some zooming. The ladder that you can see here on the left was initially the only means of accessing the upper deck, although it was later replaced by a spiral staircase that will be going up shortly, so it's been put back here for safekeeping. You'll notice a lot of beach balls, and these were there for supplemental flotation if the aircraft was damaged and at risk of sinking. Above is the wing spar, which was metal, so it wasn't all made of wood, and obviously the mechanical, cables and fuel systems were all metal. These red cylinders here are the fire control system, which was particularly important in a wooden aircraft. These were installed after the first flight with 4 cylinders per engine, but before that the engineers would simply carry portable fire extinguishers themselves. Directly below where you're looking now is a hatch into the fuel tanks. There were 14 1,000-gallon fuel tanks, and you can see one of these on the left. Now, as I said earlier, each engine uses around 100 gallons an hour, so I'll let you calculate the range. Spinning around, we'll look up at the roof, where you can see the inner workings, including a lot of wires and cables. Again, it's difficult to appreciate it on camera, but having been inside a DC-3 and other aircraft from that era, you can only imagine how impressive the size of this must have been. Now we'll move forward and into the guided section, which requires an additional tour to be booked. Now, it was originally designed to have the nose open up, as you can see in this model, so that the equipment could be loaded in a similar fashion to many large freighters now, including the C-5 Galaxy and the 747 freighter. This was also why the cockpit is in the upper deck and up and away from the luggage level, and the planned clam-shelled doors. Directly in front is the electrical panel, with the doors open so that you can see the 1940s technology. The guy sitting here had this one lever to pull, which would cut the electricity if there was a fire. And in front of that is part of the hydraulic system. Now, as I said earlier, this was the first aircraft with hydraulically actuated control surfaces. So for every pound of pressure exerted on the control yoke by the pilot, the elevator received 1,500 pounds of pressure to move it via the hydraulic system. Now you can see all of these thicker piping everywhere, and those were the hydraulic lines. And looking up above you now is the pilot's seat, and these cables are connected between his yoke and pedals and the control surfaces. This circular device, and there's another one just behind it, is the automatic direction finder, which was an old navigation system. Now you'll see this under a lot of older aircraft, although obviously they couldn't attach it to the underside of this one, as it would be washed off during landing and takeoff. The system worked by having ground-based beacons, which could be the destination airport for example, all across the world, and they sent out radio messages which then the aircraft could detect and provide a constant bearing towards it. We'll now head up the spiral staircase, which again was added afterwards, as it initially just had that ladder, which I pointed out earlier. So here we are in the upper deck of the Spruce Goose, and it's an absolute pleasure getting inside of this. The staff at the Evergreen Air and Space Museum in Oregon have done an incredible job keeping the aircraft in great shape and open for aviation enthusiasts to get inside of. Here is the propeller test station, and that guy would simply be watching the RPM of all 8 engines. Let's check out the back of the upper deck, and there are 2 APUs, which were 4-cylinder engines attached to generators. Now they would power the electrical systems and also fire up engine number 1. Once that single engine was going, it could then be used to start the other 7 engines. Spinning around, you've got a ladder up to the crew observation spot where the engineers could observe each engine and also help as the aircraft docked. This was the auxiliary oil tank, which could pump out to any other oil tank if that particular engine was burning through more than usual. And those 28-cylinder engines had a lot of moving parts, so keeping them well oiled was very important. Looking forward is the wing route. You could crawl through this small hole here, and you can see that there's many lines for fuel, oil, hydraulic systems, and other controls for the 4 engines on each side. And moving around this way, you can see right into the wing, and this pathway could be used by engineers to reach all 8 engines during the flight. Now it's hard to get the proportions in this video, but at 180 centimeters myself, I could easily have stood up inside the wing. And spinning back around will move our way further forwards. There's a whole lot of seats in here for the journalists, government and aviation industry officials. Now on that single flight, they actually had 32 people on board, and 22 of these were flight crew and 10 others. Now this glass wall here was put in afterwards and wasn't original. This was from when it was on display in the Dome in Long Beach, and people would peer in from a platform on the outside, although I'll admit that it does provide an incredible view of that engine number 4 from in here. This position here was the assistant flight engineer, and if you look closely, you'll see additional dials that they could help monitor. Now remember that there were no computers that go ping if something went wrong, and they relied upon humans to closely watch and shout out if some numbers were outside a parameter. These here are flight test equipment, including strain and vibration guides from around the aircraft. They put these sensors in particular positions, such as the hull or wings, etc., and then they would all feed into this station, where they could be monitored and documented, as they didn't know what to expect from such a large wooden structure. The next station was recording parameters from the 8 engines. Now moving forward was the radio and navigator's position. As this was designed to cross large expanses of ocean, this guy's job was very important, and they had a lot of desk space to use multiple different maps. And here I am getting into the pilot's seat, the actual chair that Howard Hughes sat in for the 1947 flight. Sticking your head out of the window gives you an incredible view and also highlights how tall you are from the ground. And seeing those 4 props lined up really is an iconic sight. This pipe here delivered cold air directly onto Howard Hughes's neck. Now while he was a brilliant designer, he was an eccentric man and had to be kept as comfortable as possible. Here's all of the usual flight controls and dials.
R stands for radial. 4360 is the number of cubic inches in the cylinders, and each engine had 28 cylinders, 4 banks of 7 each.
Another cool part of the tour is being allowed to stick your head up out through the hatch above you as well. We'll jump over to the co-pilot seat, and this was certainly more sparse in contrast with the B-17, for example, which had more dials than the pilots whose main role was just flying. Now from all accounts, Hughes was quite keen to be in control and aware of what's happening, and this cockpit layout was reflective of that. And behind them was the flight engineer's position. Here you can see 8 columns of dials for each individual engines and controls below for the throttle, hydraulics and electrical systems. Moving around, you have the fuel and oil management system and then the electrical systems. That's it for the upper deck and the tour of this incredible aircraft. It really was mind-blowing just how large the aircraft is, especially when you consider that it was built in the 1940s. The Boeing 747, Antonov AN225, the Airbus A380 all had smaller wingspans, and while they may have been bigger in other parameters, it was still very special to see. Everything I've seen today can be done in their VIP tour, which you can book when you arrive or check out their website for more details. If you enjoyed the video, please give it a thumbs up and check out my channel for many more similar videos. Thanks for watching.